Hey Bastion, how's it going, man? It's been a while. Alright. I know. It's been a while since I've really even touched C++. And so I was thinking about it today. I'm like, I need to start from square one and just, oh, let me mute myself, by the way. I need to start from square one and just, get back in the grind of things. Let me know if audio is good. I'm doing good, man. I've been having some issues with my health, with some really weird migraines. So hopefully I can go to the doctor this week. But other than that, I'm doing great. I want to try Rider and see how good it is. I'm just curious. I know you can do C++ with it. At least that's what Wizard was saying. I hope it'll get better. Thanks, man. I think I'll be fine. I've just had a lot of neck issues, muscle stress. So I think I'll be fine once I can figure that out. Actually, I don't think Rider's going to be the right way here. I'm trying to switch away from VS Code, but we'll see. Let me see. I took a break from programming until today. Honestly, I've been thinking a lot about my future career, and I don't think IT is really for me as a job. Maybe more as a side hobby. Hey, that's fair, man. I will say this, I didn't think I would like web development, and then now in my current job, I've loved what I've gotten to work on. I love my job. It's hard and it's challenging, but if I can stay in this job for a long time, I would be happy. But I totally get it. I think with C++, I don't know if I would ever want to do it for work, but I think it's really great to use it for learning. Alright, let's see. I have a lot of different stuff here. I get what you mean, and surprisingly, I'm thinking of studying to be a nurse. I definitely think it's not. Hey, that's awesome, man. No, I think doing something in healthcare or just in the medical field is a really safe bet. I don't have Neovim set up, but I'm trying to just test around and see if I like it or not. Let me look into Toolbox. I think I want to try C-Line, since I'm just using it for practice mainly. Also, I think of all this AI stuff is kind of becoming risky for new people who want to get into IT, because I feel like as someone who is a junior, it's not replacing anybody anytime soon. If anything, I think that there's going to be a pop in the bubble, just because like in my job, I've been using Claude and stuff, and I'm like, dude, sometimes it's wasting more time and money for me to be using AI than to just look up how to do it and do it the right way, you know? So, as someone who has that experience in work, I think AI still has a long ways before it's replacing a full person, but it can definitely replace smaller processes. But yeah, I think it's less that juniors will be replaced, but the work that juniors have to do will become more complex. A lot of those simpler tasks AI will probably be able to handle, but I mean, when you work at a company that has hundreds and hundreds of things to do, like every day, AI's they're not gonna have time to keep track of people like AI, you know, and the code and the quality. So it's dangerous that way. That's why you need developers still. I think there's nothing wrong with using AI as long as you're not using it as a replacement. Like, it's great for looking things up and stuff like that. Okay, so I think what I want to do here, I want to just kind of do some basic C++ practice. And here I was doing a rock, paper, scissors game last time, so I might just continue there. Okay, so right now we got some basic menu options. I see what you mean. I think the only thing I really like with AI is the autocomplete, because I feel like I'm actually productive and then I understand the code. I'm gonna be honest, I hate autocomplete because I feel like it throws off my train of thought. Like, when I'm writing code and I have something in mind, it takes away that choice of freedom. I think it gets in the way, at least. It doesn't take it away necessarily. Yeah. Also, let me know if the lighting's okay. I got a new setup. I'm gonna turn off that backlight and see if that helps. Hopefully that's better. Also, hopefully you guys can see me okay. I'm gonna zoom in a little bit. Okay, so I think I'm gonna just do something really simple, like number guesser, and I'll go here. You know, I think part of the thing that I need to work on is consistency, and I think once I start just doing a little bit every day, I will be in a much better role of learning stuff. The lighting is fine. I just find the blur a bit weird. Oh yeah, let me fix that. I had that on because... Thank you for bringing that up. Hopefully that's better. It's just kind of messy in the background. There we go. Hopefully, is that a little bit better? Also, I realize I'm looking down more than anything. Let me see if I can bring this down. And I'll bring this over here. And even one right here. There we go. Hopefully that's better. Let me know. I think it's much better, and it's not a problem if it's messy. Just adds colors. No, yeah. So the room I'm in is my office/nursery for our baby. So I was just trying to like not have it be super crazy in the background because I have all my daughter's like stuff. Yeah. Welcome to Number Guesser. I don't know. I feel like I'm at that point where I want to make sure that I'm like understanding everything that I do, and like I don't want to feel like I'm shortcutting my learning, you know. So I think just starting fresh and going up from here, you know. Have I told you that I'm thinking of immigrating to the U.S. later? Hey, that's awesome, man. I think that's cool. I will say good luck with the immigration because I know it's really crazy right now. But I think that's amazing. Yeah, I'll just do something like this. Okay, so we probably want something to handle I guess we could call it guess, and then we would just say we could have a guess. I guess, yeah, we can have our int guess, and then we can set our guess equal to sorry if I'm kind of venting about my life. It's just cool to interact with you. Hey, no worries, man. Hello, I'm also learning C++ and math to create my own game. No background in CS. I have a design degree. I decided just to make my own game. Respect the hustle. Hey, thanks, man. Yeah, I was streaming for about 3-4 months in a row, and then I got a job, so I haven't been able to stream as much, but I'm just coming back and starting fresh and trying to kind of get into kind of relearning a little bit of C++ right now, just because I haven't done it in a while. I've been mainly doing TypeScript for my work, so yeah, right now I'm just kind of warming up and trying to remember basics. And then I'm eventually going to move into OpenGL and then make something there, and then I'll probably, for my game, use something simpler like Raylib or even STL, but we'll see. I also could use OpenGL. I just know that it's going to take a long time either way if I do it in C++, so I could use a game engine. Don't know yet. Oh wait, so we have guess, and then we have I guess we'd pass in the guess. We wouldn't define it here. Guess, we do C and guess, we do C out. Please enter a number between 1 and 100. It's good to see everybody in here, by the way. It's been a minute. I feel like I got up to 300 subs and then I just stopped. And I made a video. I made a devlog on my channel, but it's been a while. I'm making a number guesser. Yeah, it's really simple, but I feel like it'll help me with very basic stuff. So we want to take in the guess, and we want to say if the guess is greater than 100, then we would say please enter a number at 100 or lower, please. And then we would just return, and then we do else if guess. I guess we'd want to set our target too. So I guess we could just say int target. I wonder if we should have a function for like generating the number, but I guess we could just randomly pick between 1 and 100. So let's see. C++ randomize number between 100. Oh, you can use the rand. If we use rand, it returns a random number. Okay. Okay, so let's try that. Int target is equal to rand, and then we can say modulus 100, I believe. Let's see. Wait. What am I doing here? There, I think that's right. So our target is a random number between 1 and 100. And then basically if our guess is greater than 100, otherwise if our guess is equal to our target, then we would basically just say you guessed correctly. This isn't gonna work, but I guess I'm just testing stuff out for now. And then this would return, so this one actually shouldn't return. I'm trying to think. No, I think this criteria should actually go in here. And then this could go in here. Because this is our main conditional, as we're saying. And then otherwise, if our guess is greater than 100, we would say I guess we wouldn't need to do 100. We would just say if our guess is higher than our target, then we would say lower. Also, let me know if you guys can see everything okay. This is really, really simple for now, but... So this would just run normally. Should just run. So let's try building it. It shouldn't work. -o main.cpp. Enter a number between 1 and 100. So I'll say 45. So that just, it says it's lower, but it we need to have it return us into the loop. So I'm guessing I need to do return here. The only problem is I don't know if it needs to be like a switch statement where it breaks. But let me see. Because we actually no. It's a while loop. That's what I need. So while guess does not equal our target, then we have all of this in here. Alright, let's try that. So it says lower. So these don't need to return, I'm guessing. Because every time we're going to do it, it just returns us to... Okay, that's another problem. So while our guess is not equal to target, I guess we'd only need to worry about these two conditionals then. And then this one, if it is correct, it would just go right here. And then this would just be let's try this for now. So 50. Okay. Let's try adding return again. Okay, that just returns us out of the loop. Okay, let me think about this. We have our target and our guess. I guess no, we would want to see in our guess in the while loop probably. Let's try this for now. Lower, and I'm guessing okay, that looks like it's working better. 50, it's lower. 20, lower. 10, lower. 5, higher. 6, higher. 7, there we go, working. Okay, that was not too bad. That just took me a second to get the right. Now let's make sure that it handles negative numbers as well as anything bigger than 100. So if I did it 101, Yeah, so basically we need to do conditional, so else we can put these in one line. So if our guess is greater than 100, or I think it's just one of those, or is it or like this, or guess is less than 0, we would just say out of range. Expected a semicolon. I don't know why this is formatting so weird now. If our guess is greater than 100 or guess is less than 0, or yeah. Hey, how's it going, New? I'm making a number guesser. I'm wondering where I'm going wrong here. It says it's expecting a semicolon, but I don't think that's right. Let's see. I'm pretty sure it would be, that's and this is or. I'm just gonna do this for now. That's weird. It should be. Am I in the, is it because I'm not in this while loop? Also, what is up with my formatting? I don't know. Okay. No, this is not making sense. If anyone in here has any ideas, let me know. Also, I'm gonna have to take a quick break in a sec to go get dinner. Cause this should just fire the else, right? Maybe is it, I'm not returning? No. Let me try this in here. Is this have to have a semicolon? Let me look. I think okay, one sec. Oh, else doesn't take a condition. That's why. Of course. So So we don't actually need an else. I think we would just do our else if here. And then we would do okay, this is bugging me. Okay, let's try this. Okay, yeah, that's definitely got some issues. It needs to be a numeric, so. Okay, I'm gonna be right back. I'm gonna go get some dinner really quick. 1 sec. Okay, I'm back. Sorry, guys. Okay, let's see. Anybody still here? Okay, so the issue we're having is checking our condition for the out of range. And I'm guessing if we do it inside of our... Okay, this is gonna drive me nuts, the formatting. Settings, C++. I guess I would just say tab. Tab space, tab size should be 3. Alright. I'll try this and see if that works. Hey, how's it going, Enerud? How's it going, man? I haven't seen you in a while. Okay, so... Please work. That looks better, that's for sure. Okay. So if we did 101... Okay, that's an issue. Also, we need to check if it's numeric. So let me look up how to check if a number is numeric in C++. S stood is digit. Okay, so I guess we'd probably want to do something like this then. Stood get line. And then this would be CN, and then is digit. I don't know if that's right. Oh wait. No, this would. And then this would be guess. Now, I'm wondering if I need to wrap is digit around CN. I just finished 3 projects to put on my GitHub in Python. Nice, man. Congrats. I need to go back and start working on older projects. Alright, let's see how is digit is used. So I guess we could have a function to say is numeric. But I guess we don't need to pass that in, so we just do oh gosh, this is annoying me. Alright. So I'm looking this up and it looks like it's a pain point to check if it's an int directly. So that's something I probably won't worry about. So I think what I'll do is try this for now. 101, lower. Okay, so this condition needs to actually go above these ones. Well, actually no. If this would be else if, and then this one should be the primary, because that's what we're checking first. We want to check first if it is out of range. Otherwise, we can then do these ones. But I also need to make sure that we're actually getting our input first. And then we would do this. There we go. Okay. Am I crazy, or was the target also 7 last time? Okay, why is it setting it to 7? Did I do the random? I think I'm crazy. I think I might have done the random generator wrong. Oh, we need to have the offset as well. So this needs to have +1 because that's just between 0 and 99. So if we had 7, okay, there we go. 8. Okay, now it's just saying 8. What the heck? What did I do wrong here? I think what's wrong is the random is seeded, and so the logic's right, but it's just seeded to give us the same every time. So we need to update it every time as well. So I think I'm just going to use the random library. I'm looking at this now, so. November experimental, so let's try that. It's driving me nuts. Get a seed for the random number engine by creating a random device RD object. Okay, so that's really interesting. Okay, and so init random number generator, and then we want to set our random device should work. Oh, it just stood random device, never mind. And then we'd have MT1 that is such a weird name for this, man. And then we'd wrap that. And then we'd say uniform int distrib. Okay. We'll try that. Okay, 87 is what it was that time. Let's try it again. So let's say 20. Let's do 87. So it's not 87. 30, 39, 45, 60, 70, 80, 76, 78, 76, 75. $71. Okay. Okay, so that's working, which is good. So that's interesting. So I guess in C++ because we have with random number generation, it's easy to seed and basically find what is random. Like that's why Minecraft seeds work the way they do. You could basically have something random is never really truly random on a computer. So what we do is we just have some sort of random device that we then have to pass into a distribution between the range that we have. Okay, I think that makes sense. Well, there we go. Easy number guesser and it's 47 lines of code. Let me see, actually, I can get this trimmed down a little bit by removing these. Since they don't need the...
Where did I think I could go?
Can you check out Skia Ganesh? I don't know what that is. Could you clarify a little more? I have the Kingdom Hearts music going in the background. I'm probably going to get copyrighted, but it's whatever. Also, Bastion, are you still on the stream? So that's actually probably good that we know how to do the random generator, number generator stuff now. So I think what I'm going to do is I'm going to put that in my notes. You know, I'll just do that on paper, actually. Never mind. I'll worry about that later. That's good to know. So we have to have a random device. I'm wondering what the MT19937 is, though. Actual number generator itself. The name comes from Mersenne Twister, which is an algorithm used 19. Returns the size of the internal state. Okay, I mean, that's better for sure. 2D graphics engine, okay. Let me look this up. Oh yeah, I've heard of Skia. Oh, interesting. So it looks like Graphite is actually the newer version now. So yeah, I think Ganesh is their older version. It looks like Graphite is their newer graphics. That's pretty cool. Thanks for showing me that, Coco. I was just confused on what that was for a second. Okay, so we got two little basic programs started. So the number guesser, I'm gonna say this is done, honestly, because it does everything that we need it to. So I can check that off, which is great. Rock, paper, scissors is not done, and I think I overcomplicated it with OOP. So I honestly think I'm gonna delete this one just because, I don't know, I'm not feeling it. Ganesh is easier. Okay, that makes sense. What I really want to do is watch a tutorial on CMake on Mac.
Motivation for this is if you do any kind of C or C++ programming for the Raspberry Pi Pico and Raspberry Pi Pico 2 using Raspberry Pi's SDK, you're going to come across CMake. Of course, it's not the only place that uses it. It's used widely in many, many places, but that's when you're going to meet it if you're kind of a follower of this channel. So I really wanted to be able to cover the essentials of CMake for absolute beginners, because just learning a few essential ideas really helps to understand what it's about and how you use it. So this really is a beginner video. Now I'm going to start from even the simplest things of how you compile a C program. Hello world using GCC. Then I'm going to look at make itself. Then I'm going to look at CMake. We're going to touch on Ninja and so on. Now, if some of those subjects are, you already know about them, they're not something you need to learn about, I'm leaving a chapter index in the description so you can just skip forward, skip over GCC, skip over make if that's what you need to do. But if you don't know about those things, I've got you covered as well. Okay, so if you want to find out more, please let me explain. Okay, so here is a simple C program. It just prints out hello world. But how do you compile that? How do you convert the source code into a binary which you can run? Well, you use a compiler. In this case, we're using GCC. And so there's the command gcc -o hello w, that's the name of the binary, -o specifies the name of the resulting binary, and hello w.c, and that is this source file here. So in one command, you can convert this C program into a program that you can run. Now, if you want to, there are flags that you can add to that. For example, you can add in some optimization. Not that this program needs any, but if you wanted to in a more complicated program, you might add in -03, the third level, the highest level of optimization, and then the rest stays the same. And there are other flags you can do as you get into more and more advanced things to do with GCC. Okay, so here we are on the command line. This is a Linux box. As you can see, here is that simple hello world program in hello w.c. So we do gcc -o hello w, that's the binary we want, and we want to compile hello w.c. That goes ahead, it's created it, and now we can run hello w, hello world. Simple as that. Now let's say you've got a bigger C program. Here is a C program that is going to print out 10 random numbers, but it's going to call this function called random normal. And if you notice, that's not here in this C code, but it does include something here called random.h, where random normal is actually defined, and the C code for that is in another program here, random.c, and here we see random normal distribution centered around 0, okay, and it's using cosine and square root and log and the stuff here. So basically, this little function here is in a separate program. So now I've got two source codes that I want to use both of them to create the final program. And so here is where that function is called, and here is where it's defined. And also notice here it's including maths.h, which means we need to include the maths library, which is not part of the standard C runtime library. So the way you can compile that is like this. So this is the output name, like we had before, the binary name. And then we've got two source files, main.c and random.c.
This guy's explaining it so much better than
against the maths library.
I've seen it anywhere, really.
Including both C command files, it will work out what to do, and it will produce this final binary for you. Now there's another way to do the same thing, and that is to compile each of these files individually. So if you compile this with a -c flag, this will create main.o.
Interesting.
If you compile this with a -c flag, this will create random.o. And then finally, you can do the same thing, but now what you do is you give it the two object files, the O files, rather than the C files, and you also link against the library for maths, and that will give you the same main resulting binary. Okay, so here we are now in that random number program. There's the first file, random.c. We can also take a look at main.c, and there it is there. So to compile that, there were two ways, if you remember. gcc -o main, that's the name of the binary, main.c, and random.c, and we also need to link -l for library, m, the maths library, and the compiler will sort all that out. It will compile both files.
I'm wondering how it knows though, like with M, that M is for the math library.
They print out those random numbers. The other way to do it is gcc -c main.c, that will create main.o. gcc -c for compile random.c, that will create random.o, and then gcc -o main, and we want main.o, not .c, main.o, random.o, and we also want to link against the maths library. There we go, and we can run main again, and there it is printing out those random numbers. Simple. Now, a few source code files can potentially be managed and compiled by hand, but at some point you're going to need some automation. Now, a tool like HTOP, which I feature in quite a lot of my videos, has 128 C files. It's not a particularly big project. It's sufficiently complex with 128 C, but it's not huge. But imagine trying to compile 128 C files by hand. Now, when you come to the Linux kernel, for example, there are over 20,000 C files, and that's not including the header files. So there's no way you're going to compile 20,000 files by hand. So you're going to need some form of automation. Now, one of the earliest and still most popular automation tools for building software is called Make. It was created by Stuart Feldman while he was at Bell Labs. The early version was completed in April of 1976, so decades ago, and we're still using it today. Make uses a configuration file called the make file to define what C files are needed and what dependencies exist between them. So here is a very simple make file. The core of it is here, is we're saying we want to run GCC to create hello world and compile hello w.c, just like we did it before. And the way that works is that it says there's a target here. If you want to build hello w, then it depends on, this is the dependency, hello world.c. So if that changes, this command needs to be run again, and this is the command that you need to do it. By default, when you just type in make, it actually really means make all. So here for make all, we're saying, well, actually what we really mean, we want to build hello w, which means it builds this, which means it runs that command. And there's also a command here called make clean, which will just remove that binary if you wanted to have a clean start.
Oh, okay, that makes sense.
Here is our make file, those three sections as we've just discussed. All you do is type make, simple as that. And as you see there, it says GCC -o hello hello. So it does the same thing, but it did it according to the make build system, and so we can just run hello world there. We can do make clean. As I showed you, that will delete that file. So now we can do make again. Let's do make all. That's the same thing as just doing make without specifying all. And if we do make clean, again we can do make hello w, and that will also do the same thing because it just depends on which entry point you get into that make file. So there you go, make has built it for us.
That's pretty simple.
Automation. Now, make files can get more and more complicated. For example, here is basically the same thing, but here we're specifying what compiler we're using, we're specifying what flags we want to use on the compiler, we specify what the source files are as a separate variable, and then down in here is dollar, and brackets means expand these variables. So you can see that I had some clever stuff going on to take all this lot and turn it into something that produces that same GCC command. Now the compiler is specified from up here and so on. And in fact, you can get even more complicated. Here's another way to do it, where you tell it you want the object files, and that you need to build the object files by using the -c flag, as I showed you previously. So you can do all these things here. You can make files fairly complicated and get them to do some fairly sophisticated things. And here's the make file when you've got two files, for example, main.c and random.c. It goes through here and it can work out what it needs to do to compile those files. So if you've got 3 or 4, you can just start listing them along here, and it's going to handle that automation for you. Now, as projects increase in size, so can the make files. Once you add in cross-platform options and other flags, what you're building, what you're including, what debug builds and release builds and builds that got certain things built into them, then they can get more complicated. The make file for the Linux kernel is over 2,000 lines long, and that's just the top level one. And each of the sub parts of
the make file for Linux is 2,000 lines long. That's
so
crazy.
We need a way to automate the creation of make files so that make can automate the compiling of the source code. So this is kind of a second layer of automation. So GCC will compile the source code, make will automate that, and now we need something that can automate the creation of the make files. And this is where CMake fits in. I like to think of it as create make or create make file, but actually the C in CMake stands for cross-platform, and we'll talk more about that in a minute.
Interesting.
So CMake uses a configuration file called cmakelist.txt. TXT, easy to edit in any text editor. Now the lifetime when you use CMake is that you define your project in the cmakelist.txt file. You run CMake to create the make file.
Okay. I think I'm getting it. So I think what I want to do is kind of follow along with this, but for OpenGL. So what I want to do here is kind of have this on the side. I'll refresh that. Oh no, I did not mean to.
So,
and then let's see. So I think if I just go into VS Code and then let me open a new window. And here, let me update really quick. And then I think I want to do is go to our, like, make a new graphics playground for everything we need. Whenever that is done. Also, I hope everybody's doing great today. Okay. I'm actually just going to delete this because we don't really need it. And let's just start here. Let's say, not CMake. Let's do int main, or sorry, main.cpp. Let's make a sources file. So source and include. And I think vendor can just go outside as well. So vendor can go here. That can go here. And then on the root we want CMake lists.text. I think I said that right or spelled that right. CMake list. Let's see. That looks right.
Main, it prints out those random numbers. The other way to do it is gcc minus c main.c. That will create main.o. gcc minus c for compile into them. Then they can get more complicated. The make file for in them. So we need a way to automate the creation of make files so that make can automate the compiling of the source code. So this is kind of a second layer of automation. So GCC will compile the source code, make will automate that, and now we need something that can automate the creation of
this isn't complicated at all, guys.
CMake fits in. I like to think of it as create make or create make file, but actually the C in
I can see why Rust developers
platform, and we'll talk more about that
like
in a minute. So CMake uses a
their compiler. Well, like I can see like why they like their build system.
Text editor. Now the lifetime when you
Hey, how's it going, Chica? Welcome.
Define your project in the CMake list.txt file. You run CMake to create the make file, and then you build your project using the make file that has been automatically created.
So I think what I'll do is I'll start by just making a hello world. I'm learning CMake right now. You had to touch JavaScript? Dude, I work every day in TypeScript and I get it. It's such a different word, such a different world. Hello CMake. Like it's weird going from TypeScript back to C++. I miss it. TypeScript is fine. Yeah, TypeScript at least you have your typing. JavaScript is like, ugh.
You then develop your code, you add code, you fix things, and you just jump around to using make all the time. Once you've got that make file created, you can fix your code, you can add to your code, you just keep running make and develop your code as you normally would. But if you add a new C file or a new header, or you've got a new dependency on a new library, then you'd go back up to step A, where you'd add in those dependencies, add in that new source code, you'd create the make file again, and then you'd carry on going that way. So you stay inside that loop just doing the make and then edit the code until you change the structure of your project, and then you need to go back up to step A. Now CMake uses a thing called out of source build. Now traditionally make files are placed in the same directory as the source code. So you go into the source directory where your hello world is, for example, and then you just run make in that directory. However, CMake is different. The make file is generated in a different directory.
That's right, it's made in the build.
Directory somewhere else. And the CMake list.txt file.
It has types, but like 15 to 20-year-old JavaScript code bases without proper docs can be rough. And funny thing, making file to be a TypeScript file and then inspecting keys does not help either. Yeah, and not to mention TypeScript isn't supported in like your local compiler. You have to have you can't just inject a TypeScript file into HTML like you could with JavaScript. Mind you, 15-year-old JavaScript code does not even support proper classes. Yeah, exactly.
Is in the same source directory, but the automatically generated files are in a separate directory so as not to overwhelm your source directory. So your source directory remains pure, here's my source, and the build system remains somewhere else separate, particularly since also it's auto-generated. Generally your source code will be hand-generated by you, and you want this auto-generated stuff somewhere else. So the way it works like this, if I've got hello world, I might have hello world.c, I'll have this CMake lists file that we talked about, and then I might have a directory, a subdirectory called build. If I go into build, I will then run CMake ... because I'm in the build directory. ... means in the directory above, which in this case means it picks.
Interesting. So let me open CMake. Where to build the binaries? Browse build. Build right here. Has Coco Cry showed up before? Do you know who he is? He's the other candidate? I don't know who Coco Cry is. I mean, I haven't seen them before. I'm just curious. Yeah.
It's up CMake list in this level. And then that will create a whole bunch of files. Most importantly, it creates a make file, but also it creates some other stuff that CMake uses. And then if I run make in that directory, then I'll get hello world binary in the build directory. So there we go. My hello world source code is in this upper directory. The CMake list.txt file is there, and then everything else happens inside the build directory. Now this is what a CMake list file looks like. This is the bare minimum. Hello W is our.
He does videos on making stuff in C. I've had him on my recommend page before. Oh, let me check him out. Oh, nice. That's awesome. Well, welcome, Coco. I don't really care. They're 15-minute one. They were like 15 when they made their first window manager in C, if I remember correctly. That's crazy. Well, that's cool. You know, sometimes I get the weirdest most random characters that come up in these streams. Like, I had Tokyo Spliff come into one of my streams, and that was like highlight, man. That was so cool. And then there's another guy with like another 1.5 million subs that came, which it's just weird because you don't expect the people that are well known, you know, to just pop in. But
Project hello W and hello W.c. You can understand here how this is going to be used. This is going to be the binary that's created by GC. This is going to be the source code we need to add, and it will go ahead and create that make file for us. Okay, so as you can see, we have the hello world.c file, and we have make CMake list.txt. Let's just have a look at that, and there you go, just those 3 lines. So now what we can do is we make a directory called build. So
yeah.
this is out of source tree, so we want to have a separate directory. Go into build. Also, there's nothing in there at the moment. And now we do CMake ... CMake and use the CMake.list file from the directory above. That's what ... means, the directory above. That will go ahead and work out its stuff. And as you can see here now, there's a whole bunch of files, and there's no binary in there, but there is a make file.
No.
If you look at it, it's pretty long and complicated because it doesn't matter. The complexity is completely hidden from us. We don't care. We just care that we can now type make, and it has done, and there we can see hello world binary, so we can just run that.
Wait, so if I just type make, and then I can do well, wait, let me look. Wait. Make didn't do anything. What did he change here?
Hello world. So now,
How did he get his binary?
actually it's pretty long and complicated because it doesn't matter. The complexity is completely hidden from us. We don't care. We just care that we can now type make, and it has done, and there we can see hello world. C make and use.
Let me see what I did wrong here. Okay, let's see. No project command is present. Project name.
The cmake.this file from the.
He didn't really show what was in the CMake list file. I'm curious, does that have to have stuff in it already?
The directory above, that's what the hello world.c file, and we have make cmake list.text. Let's just have a look at that, and there you go, just those 3 lines.
Oh, I
so
see.
Now what we can do is
Okay. I see that he had stuff in here now. So we need our minimum version. So CMake minimum required version 3.10. And then project, you can call it hello, or just call it main. I'll just call it GL practice, and then add executable main dot cpp. Okay, I'll try that maybe. And then build would do cmake dot dot. Oh, that's why. Maybe it's because it's in source. There we go. Now we should have make, and then perfect. So that's working now. Okay.
Is we make a directory called build. So remember, this is out of source tree, so we want to have a separate directory. Go into build. Obviously, there's nothing in there at the moment. And now we do cmake dot dot cmake and use the cmake.this file.
Okay, that's making more sense.
Dot means the directory above. That will go ahead and work out stuff. And as you can see here now, there's a whole bunch of files, and there's no binary in there, but there is a make file. And if we look at it, it's pretty long and complicated because it doesn't matter. The complexity is completely hidden from us. We don't care. We just care that we can now type make, and it has done. And there we can see hello world binary, so we can just run that like that. Hello world. So now we use cmake to create the make file, and then we built it using the make file. Now you can do more complicated things. This is really absolute beginner stuff. So again, you've got this minimum required version listed here.
So I'll probably, yeah, call it main. And then executable.
Define the
So I'm wondering, how do we add a directory?
main. And here we've got three source files mentioned, main.c, random.c, and random.h. These are all dependent on each other, and they all come together to build main. And also I'm saying, well, I need the maths library. So there we go, add the m minus lm, if you remember from the GCC command, add that into the mix as well. And it will take that and go away and create the make file that we need to build that project. Okay, so we've got our main.c, random.c, random.h, which is the header file for random.c. I haven't shown that, so let's just have a look at what's in there. It just defines that one function that we need. And of course, we've got our cmake list file. And now, if you notice here, it's got in add executable, you've got main.c and random.c and random.h. Okay, so let's go ahead and create a build directory. Okay, we go into the build directory, of course it's empty. Okay, and now we do cmake dot dot. It will go ahead and do its stuff. Now it's created the files that it needs. Most importantly, we've got a make file. We can run the make now. It will go ahead and do the thing. We can see there is now a main file in there. So now we can just go ahead and run main.
Nice.
And there we go, and get those random numbers. So we did the same thing now, but using cmake to generate the make file, and then the make file to build the system. Of course, these make files come with other things built into them, like make clean. That's all there as well. So it knows how to do a make clean, which means you can then do a make again. It's also important to notice that the make file has all the right dependencies built into it. So if we go ahead and edit the random.h file, which of course in the directory above, because we're now in the build directory. Okay, and we're just going to delete a few lines, but the point is that file has now changed. That file is different to what it was before. If we now run make again, the make has been built in such a way that it knows that if any of the source files get changed, you need to recompile it. It knows even about the header files like random.h. So you can see it's gone ahead and rebuilt that, and so although the program runs exactly the same, it knew to recompile, and that's of course an important part of make and cmake, the dependencies that when a file changes, the right thing is get compiled so you can carry on. Now the real beauty of cmake is revealed when you understand that it can generate build files for other build systems, not just make. So this is where I was talking about cross-platform, because here we're talking about Visual Studio, you can notice that here. So that's Windows, Xcode, that's for the Mac. Ninja is a separate build system, alternative build system that you can run on Linux. And the same cmake list.txt file can generate build files for other systems.
Interesting.
This means that you can generate files from the same thing. And that's where the real power, this cross-platform power comes from, because you need one cmake file, and yet you can build this in a variety of different places. So let's just quickly talk about Ninja, because that's the other example I'm going to give you. Ninja is yet another build system. It takes an input that is the interdependency of files. It's build.ninja, that's really the equivalent of makefile, and it orchestrates the building of them. But the key thing is here quickly. Its distinguishing goal is that it's fast. It's born from work on the Chromium web browser, which has over 30,000 source files, and other build systems like make can take up to 10 seconds before it even starts to make the file, even before it starts compiling, because it's running around trying to work out what's changed, what needs to be compiled, what's the order of work that needs to be done here. Now Ninja can do the same thing on Chromium in under a second. So Ninja is meant to replace make, and it's designed to have its input files generated by a higher level build system like cmake. So the ninja.build files can be more complicated. That doesn't matter, because cmake is actually really kind of designed to create them. So if we have now Ninja as our build system, we've got our hello world C.
Okay, so let's try that. So we have a Ninja directory. What the heck? Why is my N not working? Ninja. There we go. And inside of Ninja, we'll have a build.ninja. And then, okay.
We've got cmake list.txt. That's our old makefile directory. Well, we can have another directory now called Ninja. And if we go into there and run cmake minus G for.
So if we go to CMake minus G ninja dot dot.
Generator ninja dot dot means it picks up this one. That will go ahead and create some files, including build.ninja. And then if you run ninja inside that directory, we'll then get the hello world.
Oh, nice. Okay, that's pretty simple. That seems pretty cool.
Binary build. So this is a different build system, different files, but still created from that same CMake list.txt file. So looking here, we've got the old build directory we were just using, we've got CMake list, and we've got the source file. Let's create the directory called Ninja, and let's go into Ninja. And now, rather than just doing CMake dot dot, we're going to do minus G for generator. What generator? We want to use Ninja generator, and dot dot for the one above. And that's going to go ahead. And now in the Ninja directory here, we've got a whole bunch of stuff, including, most importantly, build.ninja. So now we can just run Ninja, and it will go ahead and build that. And as we can see here, we've got hello world binary there, and we can run that hello world. So if we go up a directory, the important thing is here we've now got a build directory, and we've got a Ninja directory, and one's using make and one using Ninja, but our source file, hello world.c, and our CMake list are untouched. So there you go, we've got two different build systems coming out now from CMake. So in summary, source code is compiled into a binary using a compiler, like GCC. Make is a build system for projects with many source files. Ninja is an alternative to make, and there are others. CMake is a build system builder. CMake generates make files or Ninja build files, as I've shown you. And CMake can also generate Visual Studio project files and Xcode files. Okay, so there you have it, my absolute beginner's guide to CMake. I hope you found it useful. Do let me know in the comments below if you use CMake. Is it your go-to tool? Is it something new you just found out now?
Okay.
I'd love to know where you are on that.
That actually was like an incredible video for getting me started. I liked that a lot. My biggest question now is, like, let's say I move source into a direct, like we have our header files in one and our source files in one. How do I update? Let me look up how do I update. Let's see. All right, let's see. Okay. So target and include directories, and then main, and then we can call it private, and then include is the name. And then add executable, we just do main.cpp. Okay, and then I should be able to just run ninja. Perfect. Okay. I think that's a really good place to stop here. Let me just get this all put on GitHub. That way it's all easily accessible. And I honestly think that's probably a good place to stop for today. Just because we were able to get CMake configured, and then next time, once we include our vendor and all of our source files, we can get those linked up so that CMake can easily make it. But yeah. If you guys are new, please feel free to join the Discord server. We're growing all the time, and also be sure to sub if you guys are new here as well. And I should be back tomorrow. Thank you guys so much for being here for the stream. I'm hoping to try and get back into like weekday streams more. Just depends on how things are going with work. But yeah, thank you guys so much. Hope you have a wonderful rest of your day. I will talk to you guys later.